Salam, our chapter, we're still in the same chapter, it's limits. We will talk today about continuity of a function at a point and maybe later over an interval, but before talking about continuity, you should know what is a piecewise function. A piecewise function is a function defined by many subfunctions that each function or each subfunction applies to a different interval. For example, it's like the piecewise function is a function formed of different functions. Each one is called subfunction. F of x equal x squared plus 5 if x less than 1, and 2x if x greater or equal to 1. This is a piecewise function. It's a function that is formed of two subfunctions. Or another example, f of x equal x plus 2 over x minus 1 if x less than 0, 2x if x greater than 0, less than or equal to 1, and 5 radical of 5x plus 3 if x greater or equal than 1. This is a piecewise function. Continuity of a function at a point. Now let's talk about continuity of a function at a point. First, we're gonna talk about it graphically. This is a curve of a function f. You can see that the curve at the point A, it has no hole and it has no jump. It doesn't cut at the point A. So you can say that the function f is continuous at x equal a. F is continuous at this point, okay? But in the point B, you have a hole at B. The curve does cut at B. Also at C, you have what we call a jump. Also the curve does cut at C. So at x equal B and at x C, f is not continuous. So a function f graphically, a function f is continuous at a point if the curve does not cut in the at this point. If the curve does not cut in this at this point, if the curve has neither a hole nor a jump at this point. It means the curve does not cut. So it's continuous at A because the curve does not cut at A. It's not continuous at B. It's not continuous at C. This is graphically. What if you have to show that a function is continuous by calculation? Property 1. A function f is continuous at x equal a if limit as x tends to a exists. It means that if limit as x tends to a minus of the function equal limit as x tends a plus of this function equal f of a. A function is continuous at x equal a if limit as x tends a minus equal limit as x tends a plus equal f of a. For example, if you have the function f of x equal 2x plus 1 if x less than 3, 5x minus 2 if x greater or equal to 3, and you need to study the continuity of f at x equal to 3. If you need to study if the function is continuous at x equal to 3 or not. To find if the function is continuous at x equal to 3 or not, you have to calculate these three values. So at first, limit as x tends 3 minus of the function, you just replace x by 3. But at 3 minus, which function you are going to use? 3 minus is less than 3, so you're going to use the first subfunction. It's limit as x tends 3 minus of 2x plus 1. 2 times 3 is 6 plus 1 7. Limit as x tends 3 plus of the function f of x. 3 plus is greater than 3, so are you going to use the second function 5x minus 2, x tends 3 plus. 5 times 3 15 minus 2 13. The first two values are not equal, we don't have to continue. You can only say then f is not continuous at x equal 3. Because the first two values are not equal, it's enough to say that the function is not continuous at this point. Another example. Example 2. If you have the function f of x, a piecewise function, x squared plus 1 if x greater than 1, and 2x if x less than or equal to 1, and you need to study the continuity at x equal 1. So at first we have to calculate limit as x tends 1 minus f of x. 1 minus is less than 1, so I'm going to use the second subfunction because it's less than 1. It's limit as x tends 1 minus of f of x. It's of 2x. 2 times 1 is 2. Limit as x tends 1 plus of f of x. You just replace x by 1. Which subfunction you are going to use? The first one, because 1 plus is greater than 1. 1 squared is 1 plus 1 is 2. The first two values are equal, so I proceed. I do calculate f of 1, limit as a1, a minus, limit as a plus, and f of a. F of 1, which one? Which subfunction I'm going to use? I'm going to use the second one. Why? In this case, because the second function if x is greater or equal to 1, so 1 is in the interval of the second function. So we use f of 1 where you have or equal to 1. That's 2 into 1 equal to. The three values are equal, so f is continuous at x equal 1. Okay. Another example now, but it's a particular case. Example, f of x equal x plus 2 over x minus 1 if x less than 1, 2x if x greater or equal to 1. And you need to study the continuity at x equal 1. So we have firstly to calculate limit as x tends to 1 minus of the function. 1 minus is the first subfunction, so its limit as x tends 1 minus of x plus 2 over x minus 1. You obtain 3 over 0 minus equal minus infinity. You got one of the limits is infinity, so you can directly say then f is not continuous at x equal 1, because if the limit is infinity, for sure it's not continuous at this point. Okay. If one of the limits is infinity, for sure the function is not continuous at this point. And that's what the definition of the continuity and plus property 1. Now property 2. Property 2. If a function f is not defined at x equal a, then f is not continuous at x equal a. If it's not defined, it's not continuous. It's so easy. Example, if you have the function f of x equal x plus 2 over x minus 1. As you know, x should be not equal to 1. X not equal to 1, x is not defined at 1, then f is not continuous at x equal 1. You don't have even to show it. It's 1 does not belong to the domain of definition, so f is not continuous at this point. Okay, another example, but in this case it's going to be defined. If you have the function f of x equal x squared minus 4 over x minus 2 if x not equal to 2, and 4 if x equal to 2. This function is defined at x equal to 2, so you can study the continuity. You might say it's not defined here, x not equal to 2, but you have the value of the function when x equal to 2. So you can calculate the limits and you can find if it's continuous or not. So limit as x tends to minus of the function equal limit as x tends to minus. 2 minus, it's different than 2, so I'm going to use the first function, x squared minus 4 over x minus 2. If you did substitute, you will obtain 0 over 0 if. So I'm going to factorize x minus 2 into x plus 2 over x minus 2. 2 plus 2 is 4. As the same limit as x tends to plus of the function f of x, I will use the same subfunction because in this case x not equal to 2, I will get the same result. Then I have to calculate f of 2. F of 2 is so obvious, it's here. F of 2 equal 4. The three values are equal, so f is continuous at x equal 2. That's everything for today. I hope I will see you soon.